Hi guys, in today's video, I'm going to be continuing with the AP Calculus syllabus. I'm going to be discussing integration by parts and the tabular approach to it. So let's start. So say we have integral of negative 4x squared into e to the power of x dx. Instead of just using a regular integral by parts, we can construct a table. So the three column headings would be plus, u, and dv. And then that would be our first row, plus u and dv. Second one would have a negative sign. And we have to find what u is. We know that u would be negative 4x squared because algebraic is above exponential. dv is e to the power of x. Now switch the sign again to positive. And for the second column, what we do is we derive u. So you get negative 8x. And then for dv, we integrate it. Integral of e to the power of x is just e to the power of x. Switch the sign again, so negative. Integral of negative 8x, differentiation of negative 8x is negative 8. Integral of e to the power of x is just e to the power of x. Finally, our last step, this becomes 0, and this stays e to the power of x. Now that we've constructed this table, it's very easy to go about solving it. We take everything on the diagonal. So plus, so this would be our first diagonal. Let me use a different color now. And then this is our second diagonal. And then this is our third and final diagonal. So we start from the top left and then we just go one down and to the right. So now let's combine everything in the diagonal. So the red diagonal, it becomes negative 4x squared e to the power of x minus, because there's a negative sign here, we just multiply out everything in the diagonal. So minus 8x into e to the power of x plus minus 8 into e to the power of x plus c. This would yield minus 4x squared e to the power of x plus 8x e to the power of x minus 8 e to the power of x plus c. So this is our final answer. So that's how easy it is to use the tabular method. However, just know that you can't use this for every integration by parts question. So now let's try another question using the same tabular approach. So we have integral 3x cubed times sine of 3x dx. So this is our integral, and we have to find out the value using integration by parts tabular method. So this is u and this is dp, because again, algebraic is above trigonometric in the table. So now let's construct our table. As I said before, the column headings would be plus, u, and dv. The second row is negative, u, which is 3x cubed, dv, which is sine of 3x. Now we integrate the second column, so that would be 9x squared. Third column, we differentiated the second column and we integrate the third column. So the third column's integration would be negative 1 over 3 cosine 3x, then negative 18x, negative 1 over 9 sine 3x, plus 18 1 over 27 cosine 3x, and finally 0 and 1 over 81 sine 3x. Finally, our last step in the table is to take the diagonals. So the first diagonal, you would take it like this. The second diagonal. So this one is slightly more lengthy than the previous one, but still this approach works. And then finally, our last one, which is like this. Again, now we just multiply everything and we get our value. So let's go about solving this. So this would be equal to 3x cubed times minus 1 over 3 cosine 3x. And then the second one would be minus 9x squared times minus 1 over 9 sine 3x plus 18x times 1 over 27 cosine 3x minus 18 times 1 over 81 sine 3x. So now if we add and simplify this, we get our value as minus x cubed cosine 3x plus x squared sine 3x plus 2 over 3 cosine 3x. 2 over 3x, second, 2 over 3 x cosine 3x minus 2 over 9 sine 3x plus c. So this is our value for the integral. So that's how easy it is to use the tabular approach. So that's it for today's video, guys. In today's video, I discussed the tabular approach to solving integration by parts. In the next video, I'm going to be discussing an AP style question for integration by parts. Hope you have a great day and please consider liking and subscribing.